Hey,
Hey, how are you doing?
pretty well. How are you?
Pretty good.
So, before we begin, I have to embarrassingly admit that I don't remember a lot of like basic algebra that I studied, like 10 years ago.
Yeah, I understand
Um,
that.
so hopefully I won't slow us down too much.
It didn't look like we actually had to use the basic algebra, like, too much. It just was saying it was similar to, I think, but I don't know.
Yeah. Well, and it even said to use the software over using it by doing it by hand.
I have pretty much everything done for turning in the describe the data.
Okay.
I just need to finish writing up a paragraph with all of our statistics and stuff like that. I only did two graphs. I did a pie chart and then a bar graph. So hopefully that should be good. But
That's good to me.
I will email that to you probably tomorrow so that you can.
Okay, awesome. So I've been thinking, is our sample size is not 30, is it? Our sample size is the total number of M&Ms, right?
Yeah.
Okay, cool.
So, which was like, I don't remember. It was over
1,600 something, yeah.
Yeah, it was plenty large.
Yes.
I'm just trying to pull my software up really quick and my computer is not cooperating. Oh, can you still see me?
Yeah.
Okay, because my screen light just went black.
I can see you, but it looks like my camera is frozen. Like
no, I can still see you and you're moving, so.
Oh, okay, cool. On my screen, I have this like goofy expression. It hasn't.
Mine just keeps going black where I'm at, so. Okay. So. Here, okay, here it comes. So I am ready, I think.
Okay. Do you want me to start off with number 3?
Sure.
Okay, given the linear regression equation, y equals 2 plus 1.5x, what is the y-intercept? And it would be 2.
Yes. And then what is the slope would be 1.5.
Okay, and then what is the predicted value of y when x equals 16? Let me just solve that really quick. Okay, so it'd be 1.
Hold on. So how are you solving? Are you just working with?
I just put x. I just multiplied 0.25 times 16, and then subtracted 3.
Okay, yeah, you're right.
Okay.
My brain just, yeah.
You're fine.
And then So for the next 7 questions, that's not what I wanted to do. Use the math self-efficiency data and make a scatter plot. I can remember.
So when you make a scatter plot, how do you know which should be the X value and which should be the Y?
Hang on, because I remember when I was reading through that, I'm like, I made a point of this. So I think for this case, the score would be Y, and then X is always the like variable or the data that you got, I think.
Okay.
But I'm not sure. Hang on.
I remember something about that now.
Yeah. So I just have to pull up my. I gotta remember how to do a scatter plot because we haven't done that in a while.
So you go to graphs.
Okay, that's right.
And then legacy dialogues.
Yep, and then just the scatter.
Scatter dot.
Yeah. Man, I hate when like you don't use something for a really long time.
Yeah.
Okay, and then what's it asking again? Make a scatter plot of the 3 data. Shapes inducing the reading. Which shape best describes this data? Oh, where am I?
I'm so bad at these.
Oh, I'm thinking a hot dog shaped, maybe?
I think so.
I don't remember reading anything about hot dog shaped things in our
Hot dog looks like. So if you look at under the manatees and power boats, there's like a little box.
Okay, there we go. Okay.
But I don't know how to like really tell which one. I would say hot dog too because it's not as condensed as the banana.
Yeah, and it's not as there's not really a curve to it, but there is a linear shape.
Yeah.
So, okay, we'll go with hot dog.
Okay. Based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model this data? So it would be appropriate.
Yeah.
So the first one.
Yeah, that's how many observations are in the data?
What? How do you find that?
Hang on. Do we just scroll down to the bottom of our data?
Well, that's what I'm wondering. Like, do we just tell like there's 139, or?
I'm thinking 139. I don't.
Okay.
Okay, yeah, 139 sounds good to me because I have no idea.
Okay, sounds good. That's confusing. Okay, Y slope. I need to remember how to do this. One sec. Okay. Create the value of Y. And there's a way to find the Y slope just by, or the Y intercept, right? Just by
Yeah.
Looking at here. Okay, so okay, so score is the dependent variable, right?
I think so. The score is the when looking at the coefficient
Right.
one.
The confidence rating is based on the score, right?
Yes, I think so.
Okay. Okay, so constant B. What's wrong? Okay, use the bathroom and then go back to bed. Okay, so I have my coefficients box,
Uh-huh.
and under B, which would be the y-intercept, right?
Yep.
I have the constant and the confidence rating mean. So
Yeah.
which one do I use?
The constant, if I remember
Right.
correctly, the constant is the y-intercept, and the confidence rating mean is the slope.
Okay, because it's showing, that's what it's showing in here under 2.4 when they plug it into the equation. So the y-intercept would be 18.69.
Yeah, and then the slope, I'm getting 12.695.
Yep, me too.
Okay, and then
Oh my gosh, this, I was like almost about to text you and be like, I don't think I can even do this until I meet with my tutor. But I'm glad I'm not slowing us down too much.
no. Okay.
Hmm.
Oops. We're on question 11, right?
Yeah.
Okay.
And I'm just trying to figure out. So when I go through putting the stuff in the linear regression thing in SPSS, I can get the the PRE1 table comes, or list comes up column, but it doesn't give me any value for 4. So I'm not sure what I'm doing wrong. So
Hang on, I
redo this. Okay, so I put a 4 on the bottom of the column score, right under 70. And I did not put anything in the corresponding confidence rating column. I just left it blank. And then I went to analyze, regression, linear, marked understand or unstandardized in the save thing. And then I pressed OK, and it doesn't give me anything.
Yeah, I'm wondering if we just have to use the equation.
Maybe. Are you able to get it to work?
I can't. Yeah, I can't figure out, and I'm like looking to see if they.
Okay.
Yeah. Let me try it one more time. Analyze. Okay.
Okay, solving it by hand, I get 69.47.
Yeah, that's what I'm getting. I just want to see.
I'm just worried because in the textbook it says to use the software for that, since it'll be a little different.
Yeah. Okay. Yeah, I don't know. So I'm going to go with the 69.47.
All right.
And so for the next one, get okay, so for the next one I get 94.86.
How are you getting that?
I just did the exact same thing, only I used 6 instead of 4 because it says because there's a positive correlation, we can use the largest X
Oh, okay.
to find.
Sorry.
the largest predicted value of y.
Yes. Okay. What was your answer?
I gotta scroll. Okay, 94.6.
I was thinking we needed different data for some reason.
Yeah, no,
Okay.
same. As far as I'm aware, it's
Okay.
the same.
How many independent variables are present in simple linear regression? Just one.
Yeah, I think. And how many response dependent variables are present? And isn't it just 1, 2?
I think so.
Also.
Okay, a company in South Dakota manufactures hard hats in the mining industry. The record measurements on all the hats they produce for quality control and planning purposes. Oh, they record measurements. The measurements they collect include hat size, circumference of the hat, and lengths of the major and minor axes. Meaning the company wants to predict size of hat given the circumference. What is the response variable? Let's see. It would be hat size.
Yeah.
Right?
Because it's the variable being predicted.
Mm-hmm.
Yep. Okay.
All right.
Let's see. Multiples. And we got them correct, so.
So it says that I got number 12 incorrect.
What was number 12? 94.86.
Oh, I typed it in wrong. 94.86. All right.
Okay, I've done that before.
All right, well, awesome.
Yeah. So it looks like we should be good just using that equation for those.
Cool. Sounds good. And I will see your email sometime tomorrow or sometime later this week, and then I'll see you on Monday.
Yep. And
okay.
Sounds good.
Cool. See you then.
Okay. Talk to you later.
Bye.
Bye.